Today, I will talk about ISO 10218 Part 2. Actually, this standard has been developed for industrial robots and robot systems. Before we prepare this presentation with my colleague Metin Özkan, and I am Ahmet Yazıcı from Eski Osman Gazi University. We are working in various project. Okay. This standard specifies safety requirement for integration of industrial robot and industrial robot system in an industrial robot cell. Actually, today we will more focus on robot systems that integrated to some fields. Actually, the standards that Part 2 contains many sections about design, manufacturing, maintenance, and etc. But today we will more focus on operational side, operational safety issues, requirements inside. The operational characteristic of robot can be significantly different from other machines and equipment, as you know. And since the high usage of artificial intelligence and there's a autonomy takes into place, the current industrial robot also have different kind of characteristics. And so we need to extend some definitions here. So in the current standard Part 2, actually there are already some definition and requirement almost sign this slide. So today we will more focus on that ones and how to extend these considering the value trace project. Since robots are capable of high energy movement through a large operational space, and we also need a high interaction with other systems and humans, so operators also can be required to work in close proximity of the robot system while the actuators on robot is running. So we need to also define some extra safety standards here. So today, this Part 2 more focus on the basics of all these possible studies there. In order, before starting that standard, as you see, it is under category of Type C standard in this area. I want to overview of the place of this standard and the relation with other ones. As mentioned before, this standard is created for industrial robot and robot systems. Actually, the Part 1 is more focus of industrial robot system. But since the safety in the application of industrial robot is influenced by design, and application of particle robot system integration required. That Part 2 is more focus of integration of the industrial robot to specific fields. It's a very diverse area depending on the applications operation. So it is very tightly connected to the standard Part 1 in terms of industrial robots there. Additionally, during the preparation of this standard 10218, there was also a section about the collaborative robots. Today we will also mention about that one, but independently there is also an additional standard for human-robot collaboration, robot and robotic device for collaborative robots. This more described in that 15066 in more details. Today, I will also make an introduction also for that intersection of this two. Okay. So in a wider area, when you consider manufacturing or industry, these two standards or other C-level standards here are also included actually integrated manufacturing system depending on the shop floor and application, etc. So this standard also refer to these ones depending on the manufacturing applications. This is another part. So when you take a look at the upper part of pyramid here, there are some basic safety standards that is referred by other standards in medium part also. So you can also find some section that refer to these standards during implementation of this the standard is the topic of today. Okay, so there are some terms of definitions that is required to be understood in this standard. As you know, application has very different applications area. We already mentioned about collaborative robot, which has some interaction with human. We can define collaborative workspaces there. As you know, collaborative workspace is safeguarded space where the robot and human can perform tasks simultaneously. Actually, this is not a cooperation or coexistence. There's the collaborative issues there. So control station is the basic that control the robotic industry robot system. Also, there are some other platforms that integrated that robot. Actually, there's the distance guard there. Actually, it is not enter the close the danger zone, but prevents for reduced access for human or other objects. Actually, there are different type of that guards. There are some light curtains or some physical objects enclosed there. So there's also integration, which is about application of that robotic system with working collaboration with other systems. As you know, full integrated is known as the human. So we mentioned about integrated manufacturing system that consists of one or more system in a coordinated manner linked by a material handling system, etc. So that industrial robot cell is more focused on one or more robot included in. So industrial robot line, a safe state, simultaneous motion also defined there. For also operating space, we consider the details of the standards. There are some terms actually. The operating space is important, restricted space, maximum space, and safeguard one is so are important. So that restricted space, the portion of maximum space is by limiting device that establish a limit which will not exceed. Actually, I want to underline the limiting device here because the limiting device can be somehow mechanical or non-mechanical. So in our project also during this presentation, we more focus on non-mechanical limiting devices here. Also, for in terms of safeguard space, defined by the perimeter of safeguarding one. Actually, in the various project and validation and verification also mentioned in that standard, there are different part proposed for that one. So from A to I, there are some verification and validation methods that is asked in this standard. So during this presentation, we more focus on this visual inspection, practical test, measurement, or observation during the operation. Actually, the original standard, for example, asked for visual inspection, more focused on human side. Okay, a human can make a visual inspection, but when you consider that high perception issues, since the quality of sensor increased also. Some of the inspections mission also can be realized, but some systems, some test system actually, including the practical test and measurement. So this will also increase the automation during the verification validation process. So we will also mention about this one. These are some terms and definitions about that is given in the presentation. Actually, in that standard part 2, there are many subsections include requirements. So here we more focus on the green subsection. For example, 5.4. More about limiting robot motion. It has actually 16 requirements. We will today we will present some of them, not all of them. Also, safeguarding, there are 74 requirements. So for collaborative robot operation, also there's the interaction with the standard 15066. There are 28 requirements. Today also we will cover some of them to show what's going on there. There are many other requirements. These are more focused on installation, design, and etc. So the green ones that we more focus on operation and safety issues. So we more focus on this requirement during the standards.
Sim.
So the first section is about limiting robot motion. Okay. So what is the meaning of limiting motion? The limiting motion of the robot system can be accomplished by integral to robot. There are safety rated soft axis or space limiting or some hard stop provided by manufacturers, or installing some external limiting devices. There are two methods to realize that ones. Here, in terms of meaning, it is somehow to restrict the space in which robot may perform tasks. So the restricted space can be smaller than the maximum space of the limiting devices. So there are two methods focused can be. First, mechanical limiting device, but, as I mentioned before, or non-mechanical devices which limit the robot. Actually, this device they do not limit the robot motion themselves, but rather initiate a stop to robot control systems. So they have a little bit different functionalities. There are also possibility of applying some alternative methods. So this all should meet the requirement of this standard part 1, consistent robot. So when you consider dynamic environments, autonomous behaviors, and interaction with the human, non-mechanical limiting is more important for us actually. Actually, this standard clearly defines stopping distance. It's important here, either using mechanical or non-mechanical devices. That stopping distance actually depends on some properties of robot doing the operations. One is the actual load of the robot. Depending on the load of the robot, some velocity or some safety rated soft axis or space limiting can be set up there. So this also required there's a good option. If the speed of the robot is limited by a monitoring system that satisfies the other standard, the restricted space may be based on the configured speed limit, actually. Currently, if there is not a monitoring system overall there, that limiting mainly based on the maximum speed of the robot. But if there is a monitoring system, then that speed limits may be changed depending on the robot laws and environmental conditions. Actually, one point here to be careful about. There are, for example, some obstacle avoidance sensor, okay, on the robot or the environment. We cannot use that ones directly for that monitoring systems. We are asked to use another safety device for the purpose of limiting motion, which complies to that other standard. So these are some example requirement and verification validation method that is proposed in standard for just about mechanical and non-mechanical limitings there. This is about control system for non-mechanical robotic mean limiting. There are also some practical tests. The stopping distance associated with the limiting means has been included in the calculation of restricted space. As you know, if there is a monitoring system provided by external sensor, safety sensor, then the stopping distance can be also may change depending on the velocity and load of the robot. So this requires an additional monitoring system. So when non-mechanical limiting devices are used, that restricted space also determined based on the actual load. Actually, here's the yellow one is restricted space. It means that can be changed if there's an additional monitoring system. Also, if the speed of the robot is limited by the monitoring system, that monitoring system provides some input to the robot speed. Then restricted space can be also set up depending on the actual speed. Otherwise, the requirements say that use the maximum speed of the robot. So some additional safety monitoring system will help to use the robot system with integrated parts in a more efficient manner in terms of speed. So in this values project, in use case 11, it's the automated robot inspection cell for quality control of automotive body in white. There's a system like this. It monitors whole automotive body for quality inspection case. There's a requirement that we are working on. The trajectory plans must confirm the position.
Sim, o Boni me ligou perguntou se aqui tinha net. Mas falou que lá não tem nem energia, sério.
Excuse me, is there any question?
Obrigado.
Okay. So we focus on this requirement about the position and velocity concept of the robot joints. So in our infrastructure can be a real simulation system. We are currently testing on this. It can be a real system, okay? So that joint limits or robot front side also some queries can be put in that system. We developed a Marvel tool actually here. It reports some outputs related to that concept, both position and velocity concept. It provides us that limits. Let me mention about a little bit about that Marver tool. Actually, it's a kind of monitoring tool developed by that whole system. Very fit to objective also of this standard. It's a model-aided runtime verification for robotic system, actually the extension of Marver. This tool is intended to facilitate and automate the verification of robotic system during the execution. And it becomes more effective with the add-ons that can be used with safety verification of robotic systems. So later I will also mention about some other part of that Marver tools. Actual Marver is composed of three parts. Marver M, here it is not on that slide since there is no model-based verification here. Marver R is main engine part, and Marver S provide us some services related to depending on the application actually I will mention about. So this Marver tool is able to monitor that robotic system and confirms is there any exceed about the limit about position and velocity limits. So let me go on. In this standard, there is another subsection about safeguarding. Actually, there are 74 requirements, but since we have limited time, I will mention about some of them. Actually, a typical safeguarding system can be seen on the picture. There are some mechanical part or some also light curtains or e-stops or some light devices that is designed to prevent the cell. But actually, this is not our main focus. We have some interaction with robots, but it is also important to know that some bits of these. Actually, for this section, that minimum safety distance definition is critical for us. And there are several definitions for the guards or protective device or some minimum safety distance definition for providing clearances. It also actually depends the speed of the robot there. I will not go through all the details. So I want to also mention about that tool, Marver tool here. Actually, here we develop and for as mentioned before, there is Marver R. Some queries can be entered here. Here, the queries, the trajectory plans must not cause any collision with robot itself and the automated body. So here in this requirement, actually it is not actually implementation of this one, but in terms of this standard, this setup helps us to correctly measure the robot platform and the distance with other objects, including automotive body in white or some other objects in the environment. This can be hooked actually. I will mention about in the some other section. So here that Marver tool we use a service here addition to Marver R. We use a Marver service online distance tracker here, ODT we mentioned. It actually take robot system under test configurations. It takes all the CAD files, CAD models from robotic representation about body in white from here, CAD model object in the environment, and all the safeguards actually. This ODT takes CAD models of all the safeguards plus automotive body in white. That is other than robot system. During the task execution by robot, ODT provides minimum distance between robot links and the safety guard equipments, including automotive body and wire. And that malware R check the minimum distance to safety guards, determine if the safety guards are properly placed or if there's a possibility of collision or not. Actually, this is a kind of online monitoring system that check at each time all the distance between the robotic platform and the other objects in the environment. Actually, in this setup, all these objects are static objects. For these, I will mention about dynamic one human in the upcoming slides. So it is actually a service that is integrated to this one. If you watch the presentation for this tool during that some of the meetings, you can see there are several other services can also work in line with this malware R. Actually, there are some other parts about this safeguarding, sensitive protective equipment. This standard, some definition about that ones. For example, if a presence sensing protective equipment is used, it's advised that operator can circumvent the detection zone. It can be actually a sense based on sensor and hardware, by claiming on the parts of the machine, etc. There are many other details that I will not. I will skip them. So these are some requirements all related to this one. For example, by measurement, the standard asks the minimum safe distance formulas to determine the minimum distance of sensitive protective equipment for all direction of the approach using the maximum extension of moving parts towards the direction of the approach. There are many requirements about that ones. The detection of zone presence sensing device shall be used, shall be positioned and configured so that a person or a part of person will be detected through the detection zone. Actually, this is more clearly explained in upcoming presentation. These are some other requirements also related that measurements or minimum distance issues. There are also a section about safeguarding during the manual loading or unloading or handling situation or some other task-related issues. Okay. When a presence sensing is used to detect the operator in a shared workspace, the detection zone of the device covers the entire shared workspace area. It is critical that if there is operator inside that workspace, the device that plays for covering that zone should cover entire shared workspace. There will be no blank point in the environment. So the last part of the presentation also, the requirement that I will mention about collaborative robot operation. As you know, there are different interaction with human and robot. It can be isolated ones, coexistence, synchronization, cooperations, actually collaboration. As mentioned at the beginning of the presentation, robot and human work together within a collaboration workspace here. So they are at the same time can handle the same object or do some task on the same object. Okay. Actually, in the standard, there are 28 requirements for this issue, but as I mentioned, 15066 has more details that the standard also refer to that one. Actually, for safety issues, putting some additional sensors is also important and critical to satisfy these issues here. Collaboration is important between person and robot that sharing a common workspace. Actually, it is only for use for predetermined task, which means that, okay, we have already know the nature of the task. It is not fully autonomous on the robot side. We have some, we know the details, okay, of the task. It's possible when all required protective measures are active. Actually, this is critical for human-robot collaboration. If you consider some other parts of this requirement, it is more some of the requirements focus on isolated robot cell using some mechanical limiting device, etc. So this action is possible when all the protective measures are active that is mentioned in this standards. Actually, also another requirement for robot with features specially designed for collaborative operation complying with the standards here. Actually, there are some methods for this. Due to potential reduction of the spatial separation of human and robot in the collaborative workspace, physical contact between the human and robot can occur during the operation. So the protective measure shall be provided to ensure operator safety at all times. So it's also for this subsection, there are some parts, but I will more focus on operation in collaborative workspace. I will just mention about these ones. These are some general requirements about safeguard or detection. When you say safeguard, current, actually we are not just mentioning mechanical safeguarding, also non-mechanical ones. There are some requirements for this about these requirements. Actually, there are some requirements for also collaborative workspace that define what should be the properties of such a workspace. Any detected failures of the selected safety feature of the collaborative operation shall result in a protective stop according to the other standard requirements that we mentioned before. So safety-related monitor stop is critical here. If there is no person in the collaborative workspace, the robot can operate autonomously. But if there is a person in the collaborative workspace, the robot shall stop moving and maintain safety-related monitor stop according to the standard. This is one part, actually. But there's also another extension, speed and separation monitoring. The robot system can be designed to maintain a safe separation between the operator and robot in a dynamic manner. Shall use robots to comply with the requirements of that one. So the robot speed, minimum distance, minimum separation distance, and other parameters shall be determined by the risk assessment. Actually, more information is given in this standard. More focus on collaborative robots there. During the preparation of this standard, there was under development, but you know this already published. For example, they are required if using speed and position monitoring technology, robots in collaborative space meet the requirements of that ones that mentioned before. When you consider value trace project for collaborative robot operations, we also use the same malware tools here. Okay. Here we use the service, malware service, malware as online human tracker here. Okay. That OHT takes the parameter file for robot and human representation. Okay, what this one or what that one. So during task execution by robot, that OHT provides minimum distance between robot limbs and human limbs. As you see, there are two pictures. In one, the person or colleague is in the upright position, so you can see all the calculations here. In the pictures on the right-hand side, the person is a different position, so you can see all these calculations are realized during that one. Okay. So the minimum distance between robot limbs and human limbs are provided here. So depending on the requirement related to the minimum distance, velocity, etc. The system also take all the parameters from under test. And then the system can trigger a safety-rated stop or speed using for the separation monitoring requirements of this standard actually here. We also have some works related to that section, but here during this presentation, I more want to focus on this. So actually, this is just a summary of the standard and what we are actually doing, covering some part of the standard, especially focus on such an online monitoring system that can be used both during runtime or during the verification process in simulation side.